Hi everyone, this is our fifth lecture in computer programming course. To see this web page on GitHub, please write github.com/laydinbakar and click on the computer programming BTU, then click on this lecture 5. In this lecture we will learn about the Python modules, but before that I'd like you to set something in your vimrc file. First, please make a directory, so-called lecture 5, and go in that. At the end of this lecture, you will again push your codes into your GitLab page. So it's quite important for you to do this directory correctly and follow these instructions correctly. Save your files into this directory. I'm making my lecture 5 folder in my home directory, and then I just go to that file folder. Currently I don't have anything here. Now let's open a Python file here, which is very simple, like prints hello. As we learned in our last lecture, we can just run this command without leaving the Python, so I pressed escape to go back to the command mode in Vim, and then I can just type my command with this exclamation mark python3 a.py. When I press enter, I can just see I forgot to save, sorry, you should first save it and then you can run python3 a.py. then you can see the result or the output of your Python code. So we just executed the a.py without leaving Vim. When we press enter, we just go back to this a.py file in Vim. Now it is possible to do that every time, like running this python3 with a.py, typing this code here, typing this command here and pressing enter, or we can just make this process automatic following these instructions here. To do that, please open your vimrc file with Vim and paste this line into your vimrc file. When you do that, when you press F2 after saving your document, this command will be executed automatically. So we just assign our F2 key to run this python3 space the name of your Python code .py command is executed automatically when we press F2. Like, to do that, I will show you how to do it. You can just open this vimrc file in your home directory, and then you can copy this line from here, copy it, and then you can just press O anywhere in your vimrc file. You may not see your vimrc file exactly the same as this one, but in my vimrc file the settings are like this. So you can just press this line here by just clicking right click and then select the paste. Now when you have this line in your vimrc file, as you see I have here, and if you save your vimrc file here, when you open your a.py again and press F2, you will see that your command is run automatically, F2. Okay, now when you press enter, you will go back to your a.py file. Now I will remove this a.py because we will not use it. I'm again in my clean lecture 5 folder, and let's start learning about the Python modules. These Python modules are actually some scripts written by Python experts, can be used for some operations in Python, like making some operations automatic and making them efficient. Okay, the first module we will learn about is OS, which stands for operating system, and it provides a way of using operating system dependent functionality in Python. Some of the useful operating system OS module methods are listed here. I will not open a Python file, but I will use my command line to show you what these methods do. You can just use os get cwd to print your current working directory. If you do this in a file, you will not see anything surely. If you just type print like this, your code will print your current working directory. So this can be used instead of pwd on the command line. Okay, so we can just print our current working directory in Python by typing this, but you should of course first import the os module, then you need to run this command. I'm running wrong. It is get cwd. So this is our current working directory in Python. You can clean this Python command line framework with Ctrl L. Then you can just use os mkdir to make empty directories. Like you can make os mkdir, for example, folder 1 with this command. You will not see anything as output, but if you just press Ctrl D and do ls, you will see that folder 1 is here now. We just made this folder 1. In Python 3 we can also import os first, and we can also use os make dirs to make folder trees, the directory trees. Okay, directory trees. What I mean by tree is like you can make couple of folders which are inside of the others, like this one, for example. If you use this command, you can make folder 2 in one. If you press Ctrl D and ls, folder 2 came here. If you ls in the folder 2, you will see that there is also in one folder. Okay, so this make dirs is used to make a directory tree. This mkdir only makes a directory, only makes a folder in the current working directory. What if you use this command, os mkdir command, to make a directory tree? You will get an error. Os mkdir, let's say folder 3, and in one, for example, you will get an error saying that no such file or directory, because there is no folder 3 in your working directory. But to make it, you can just use make dirs. Then you will not get any error. Okay, folder 3 is here, and in one is in the folder 3. Now chdir can be used to change the current directory. Currently we are working on here in Python. When we import the os module, we can just change our directory to, for example, folder 2 using the chdir command. And when we use this get cwd again, we can see that we are now working in folder 2. We just changed our directory to folder 2, as you see. We can list the files and the folders in our current working directory using os listdir. And as we know, we have this in one file, in one folder, in the folder 2 directory which we are working on now. remove and rmdir commands can be used to remove the files only and folders only. To check this command, first go to the folder 2 and then just use touch command to make a file, for example file.txt here. Okay, then start Python 3, import your OS, and then get your working directory. You are now in folder 2, list the files you have in one folder and file.txt as you see here. Then you can use os rmdir, os.rmdir to remove only files. Let's try first to remove folder. You will get an error. Sorry, I used the wrong folder. Let's make os mkdir in one back and then try to remove this folder with remove command. Then you will get an error because it says it's a directory. You can just remove files with the remove command. Os remove like file.txt, for example, you will not get an error and you will remove the file.txt. You can check it with list there. You only have a directory now here in folder 2, and you can remove as we just made it here accidentally using the rmdir command in one, for example. Now when we list the files and folders in the current working directory, we see nothing, and our current directory is cwd. Okay, you can check if a path exists using this command, and you can check a path's size using this command. Let's change our directory with oschdir to one back, folder 3, and one back and folder 3. Excuse me. And you can just check listed files and folders in the directory. You can check if in one file exists and in one folder exists, and just check if in two folder exists using this ospath exists command. Ospath exists in one, it will print true to us. If we check in two, it will print false to us. We will use these commands in the following lectures with some other options, like with if statement. We will say that if in two file exists, do nothing, but if the output of this command is false, make into file. Okay, so these will be more meaningful when we use these in the future, but currently it's just for you to have an idea what you can do using the os command. Okay, and you can also check the size of in one, for example, using the os path get size in one, and this is like 496 kilobytes bytes, sorry. Okay, the second module is argparse. We can use this argparse to parse some of course we can also use this os when we write our commands into files, like open your v0th code, for example, .py, import your os module, and then you can just print your current working directory, for example, get cwd. You can save it and you can press F2 to see that you are working on here. When you press enter, you will go back to your file, and like you can print if the OS path exists in one in your current working directory. When you press F2 after saving, when you press F2, you will see that in the folder 2 there is no in1 file, because it prints false. Okay, just save this code and exit. Now in the argument parser, we need to use a code block like this one for defining some arguments we can read from the command line. Like when we run this Python 3 zeroth code, we may need to enter some information, like it can be a string, it can be a float, it can be a integer, float, or string, like this, or a like word. Okay, so in order to define these kind of information in the command line to our Python code, we use this argument parser module, which is so-called argparse, and like we just use this code block and we can add here any of our arguments. Like first, write your first code as this one. I just write these codes, so I just go back to my lecture 5 folder and copy my previous codes from my lecture 5 codes folder. This is my first code. I will open from here, but I recommend you to write these codes and save as like firstcode.py into your lecture 5 folder, because you will upload your files and folders into your GitLab page. I will show you how to do that at the end of this lecture again, as I shown in our lecture 4, at the end of lecture 4. Okay, now to use the argparse module, we should first import this argparse module here. Then we need to write these 1, 2, 3 and 4 lines. We don't need this, we just need to write these 4 lines, and then we can use this argument, or we can add other arguments like here. Okay, and when we define the other arguments like this, we can use these arguments like print arg1 or print arg2. Okay, now let's save this. Let's save and exit from this code and try to run this firstcode.py. Our first argument is like first, let's say, and our second argument is second. When we press enter, it will print our first argument here and the second argument to here. We can also make some calculations with these arguments, like multiply this first argument by 2. It will just multiply this string with 2 and print here, or like you can add to here arg1, for example. It will again print second and first arguments to here. You can also use like space between here, and you can calculate. You can just print this second argument and first argument like this. Okay, we just use the arguments to add some like variables, or to make some definitions outside of the code, and to give some information to the code in the command line, like this one. You can add anything to here. You can add anything to here, and you will see that anything came here as a second argument. You can change this like something, then you will see something for your first argument. Okay, now to do that, our code block is just this one. Okay, just save this code block to somewhere, and when you use this argparse module, you can just copy this one from your template script and then use in your scripts. Here we can add other types, like this is a string. We can also add an integer or like float, or we can also add some help message to here, which can be printed just by using Python 3, your code name, and then -h. This -h prints this help message, and then it shows you your arguments here. If you add a secondary argument like we did here, when you run this help message, you will also see your secondary argument here. Okay, first argument, second argument. You can rename these arguments, which we will see here. Now let's make an example to read integer, float, or string. I will again copy my second code from here. At this point, please pause this video and then write this code. Then you can do whatever I do from now using this code. You can just follow me. Here we add 1, 2, 3, and 4 arguments. This code calculates our body mass index, BMI, and then prints our body mass index to us. Like, first let me show you how it works. Now let's say I just come to a directory and I found that I've written a code which is so-called second code.py, and I don't know how to use it. What I do first, I just type Python 3 second code.py and then hyphen or -h, which prints me the help message. Okay, and this help message shows me whatever I can do, what I should do when I use this code. It says that with -n option, please enter the name. With -a option, please enter the age. With -hg option, please enter the height in meters. With the -w option, please enter your weight in kilograms. So okay, I can just use this code now. Python 3 second code.py -n my name, -a my age, -hg. We cannot use -h only for any argument, because -h is already used for the help as default. So we just use this -h option to show this help message and exit. So instead we can use like couple of letters instead of one letter. hg, height 1.8 meters, in meter it says, and then my weight like 75 kilograms. When I press enter, it just types you are Levent, was born in 1988, your body mass index BMI is like 23 point something. Okay, I think this value is something good. Your BMI should be in between like 19 and 28 if you are at the age of like this, I don't know. You can just check it on the internet, but our code just prints, just reads this information first from the command line and then prints this one. Like you can also do it for someone else with someone else's name, someone with age 23, height 1.75 for example, and then weight 80 for example. Then you can see that someone was born in 1999 and his or her BMI is 26, like this. Alright, so this code is not only written for Levent, who was born in 1988 and whose BMI is this, but this code can also be used for anyone else with the information of age, height and weight. Okay, so this is kind of a general code calculating the BMI. Alright, how did we write this code? We just added some arguments to here. In our first code we had a template, as I said to you. In this template, let me try to make this figure larger for you to see it easier. In this template I said that you can add any arguments to here with any name. I just put argument 1 as a name here, but you can also put like argument whatever, or like n, a, name, age, height, weight, w or something. Okay, and we added 4 arguments here as name, age, height and weight. And then we had this line args. We defined something as args, which is parse args. That line is also here. I didn't change that line. And then we defined some variables as arg1 here, which is args.argument1. I also made some variables here as n, a, h and w as args name. This word here has to be the same as this one. This word here has to be the same as this one. This word here has to be the same as this one, and this word is the same as this one. Okay, then I just decided that the types of these arguments are string for name, integer for age, and float for height and weight. Okay, using these types I printed something here. Like if I written string here for height, I wouldn't be able to make this mathematical expression, mathematical operation here, right? Like I have a mathematical operation here which is w over h square, which is the calculation of BMI. If my age, which is height defined here, was string, I wouldn't take its square, right? Or I wouldn't use this h square in the bottom of this division. Or if this was an integer, maybe after this division I wouldn't get a float. But when I write this, I needed to convert back it into string to print it in between the strings. So this is something important in this code. My age is int. I just subtracted my age from this year to calculate when I was born. So I just choose it as integer, for example. I would also be able to choose it float, but the result of this one would be a float. then I needed to add here as to print this one as integer, because years are integer, right? We don't have 1999.2, we just have 1999 as in the last example. So I just changed this, choose this integer, and my name is string, and just I added it to here. Okay, please write this code and try by yourself for different examples. Now I will save this code and exit. I now have my first code and second code here, and I just go back to my direct repository to see what follows this example. Okay, now here we read integers, floats and strings using argument parser, but we can also read list items. Now we have an example here. This example says that write a code calculating the linear velocity of a point located on a rotating model. Now we have this circle here which is rotating around this origin, which is located at 0, 0, 0. Maybe it's not given here, and the angular velocity is 0, 0, 1, which is a vector. Using your right hand rule, you can put your four fingers showing the way of this arrow, and you will see that this your first your thumb shows U, which means this is a plus, and the angular velocity can be represented as vector as this one. This R is the position vector from the origin to the point, and when we rotate this circular table, for example, what is the linear velocity of this red ball, for example, which is shown here as U vector. Now we are asked to calculate this one. Figure shows the model rotating at 1 radian per second around the x3 axis. X3 axis is given here. Calculate the linear velocity U, which is given here, of the red point. The position vector from the origin, okay, it's given here in the question, to the point is R100. Okay, so the location of this point is 100, so the position vector from the origin to the red point is also 100. Then now the solution, the linear velocity is calculated by just taking the cross product of the angular velocity with the radius, or with the position vector. To make this calculation with the cross product, the result of this calculation of the cross product can be written using the basis vectors E1, E2 and E3 as here, and these omega 2 R3, omega 3 R2 are the components of this omega and R, which are given here. Okay, 1, 2, 3 are the vector components given by omega 1, omega 2, omega 3, and R, which is position vector R1, R2, R3. When we do this calculation, we can just obtain U in vector. We can show it like this, or we can show it using the basis vectors E1, E2, E3, or you may learn it IJK in your math calculus classes. Now we will write a code doing this calculation, and we will call that code as thirdcode.py. Please you type thirdcode.py and then write this one. Write this code by yourself. Now here we need to we can simply write omega is equal 001 and R is equal 100, but according to our lecture we just want to learn how to use the argparse. So we want to read the omega components and the coordinate components C1, C2, C3 here, R1, R2, R3 here as floats from the command line. Okay, so we just write two arguments here. One of them is omega, one of them is coordinates. But in our last example, let me show from here, we just read integer, float or string, but in this case we want to read lists. So we want to read omega 1, omega 2, omega 3 as list, and like the radius 1 or position vector 1, position vector 2, position vector 3, or coordinate 1, coordinate 2, coordinate 3 as lists from the command line. Then this is just the equation given here, like in the second line here. This is just this equation. I cannot select this one, I don't know why. Okay, we calculate the linear velocity and then we just print our linear velocity as this is a vector. Okay, so to use this code, again we can just type Python 3 hyphen h, Python 3 third code hyphen h, and we can see that like enter angular velocity, but we need to enter it like W1, W2, W3. So we can just type Python 3 third code.py hyphen W, like it's given here. Our omega is 001, 001, and hyphen R or hyphen C here, which is 100, which is 100. When we press enter, it will print our linear velocity at this point. But if you just imagine that if this system rotates at this speed with 1 radian per second with a radius of 100, at the point P the linear velocity should be 1, right? But in what direction? The linear velocity is perpendicular to the position vector. So if we just rotate this P to here, then the position vector will be like this, and our linear velocity will be again perpendicular to this position vector in this way. But in this way, if we work on our x1 axis, for example, the position vector should be perpendicular to this linear velocity, so the linear velocity will be in the x2 direction, right? So our linear velocity should be 0, 1 and 0. Let's check it. You will see that our linear velocity is 0, 1, 0. You can calculate your linear velocity at this point, for example, the point P in located in 0, 1, 0 here, 0, 1, 0. So you should change your position vector to 0, 1, 0. Then you will see that your linear velocity will be in this direction, which is x1 but minus x1, and the magnitude will again be 1 because we just multiply 1 by 1. So it is x1 direction but minus. You can just calculate it in, for example, minus 1, 0. Minus 1, 0, 0 is here in the coordinate system, and your u vector will be in the direction below to your monitor, so which is minus x2 direction, right? You can just press and see that your velocity vector in the x2 direction but in the minus direction. Now these are some things easy we can imagine, but we can also calculate it like 111 to if our omega, which is angular velocity, is not 1 but 1.32, for example, radian per second, then your linear velocity will be in the x direction 14.52 minus, and in the y direction 1.32, for example. Okay, you can calculate the magnitude by just taking the squares of these, adding them to each other, and taking the square root in meter per second. Alright, so this is third code. .pi can be calculated the linear velocity at anywhere if our system is rotating around origin, like in whatever direction. Okay, so third code should be written by yourself and added into your lecture 5 directory, and you will add this lecture 5 directory to your GitLab at the end. Okay, the example has finished, and the argparse module is like this. We can also add another option here as action true, like our Python 3 code is this one. If we just say calculate linear, when we press enter, when we add another argument as action true, if we put this option here, it will calculate the linear velocity. If you don't put this option, it will not calculate the linear velocity. But because we have not learned about the if statements, or like for loops, while loops, I will not show you that example for now. We will see that example in the following lectures. Okay, for now it's enough for you to know about the argparse like this. Okay, you can read integers, floats, or strings like this one, or you can also read like lists using this an args tree and metavar and three arguments here. Okay, the type is float here. You can also make this type like string or whatever. Okay, you can just create lists from your command line using the argparse. The following module is math module, and after that math module we will jump to NumPy. So I will have a break here and I will continue with the next video.